What's good, math family? In today's review, we're going to look at the top 10 must-know methods to factor quadratic equations and trinomials. The first method is just how to factor trinomials that have a lead coefficient of 1. So we have to be mindful of the standard form for quadratic equations and trinomials. It's going to follow the format ax squared plus bx plus c. And we know that when we're looking at these factors, we want them to multiply to give us 15, but add to give us 2x, the b term that's in the middle. So this is why you see your teachers tell you to write it out, because it's easier to see. And if we want a positive middle term, that means our larger number, 5, is going to have to be positive. 3 will be negative, so that when we multiply it back, we'll get that negative 15. In our second example, when we repeat this process, it's going to be a little bit different because of this addition sign. The addition sign lets us know that the signs of the factors are both going to be the same, whether they're both positive or negative. And after we write out the factors, this is what we're going to have. And a lot of times students are going to think 12 and 2, but if both those signs are negative, negative 12 plus negative 2 will not give us a negative 10. So we're going to have to use 6 and 4. So we have x minus 6 times x minus 4. And when we multiply this back, we'll get the positive 24. And when we add, we'll get the negative 10x in the middle. Method number 2 is going to be GCF factoring, where we pull out a common factor. And this is a two-step process. So we're trying to look for the largest common factor for all three terms, which in this problem would be 4. So after we divide everything by 4, we're going to have x squared plus 5x plus 6. And now we're just focusing on what's inside of the parentheses. So we're looking for two factors that multiply to give us 6, add to give us 5. And we don't have to worry about the signs because they're both going to be positive. So this is going to be our answer. Now, one thing I want to touch on real quick before we go to the next problem is the difference when the trinomial or quadratic equation is set equal to 0. If it's set equal to 0, then you have to take each factor, set them equal to 0, and solve. So 4 is equal to 0? No, that's not true. So that would be an extraneous solution, or one that we toss out. But if we continue, we'll have x plus 3 is equal to 0. So x is equal to negative 3. And if we do the second factor, x plus 2 is equal to 0, we'll get the answer x is equal to negative 2. So when the equation is set equal to 0, we're going to use the zero product property to solve. But that's only if the equation is set equal to 0. In the second example, we're going to do the same thing. So we look at these three terms, and we could pull out a greatest common factor of not just 3, but 3x. So when I pull that out, we're left with x squared plus 9x plus 20. And now when we focus on this, we're looking for factors that multiply to give us 20, add to give us 9. So we're going to break this down as x plus 5 times x plus 4. Now, this one is a little bit different compared to the first example, because if we set it equal to 0, especially with the exponent power of 3, we should have 3 different answers. So the first one, right, is 3x is equal to 0. So when we divide by 3, x is equal to 0. That is our first factor. Then we go to the next one. X plus 5 is equal to 0. So we know x is equal to negative 5. And then for the last factor, x plus 4 is equal to 0. Our last answer will be x is equal to negative 4. Sometimes you'll see the answer expressed like this. X is equal to, and in braces, they'll put negative 5, negative 4, and 0. So just be mindful that they may express this way as well. And we're going to go to our third method now. Method number 3 is going to be the slip and slide factoring. And this is very useful when our lead coefficient is greater than 1. And it's very similar to the AC method. So what we're going to do is multiply A and C so that we could turn this into a polynomial with the lead coefficient of 1. So once I rewrite this, this should be the polynomial that we're going to try to factor. And once we break this down, what we're going to get is x plus 6 times x minus 4. Now, the reason students get this wrong is because they don't understand the concept of going back and dividing by that same a that we multiplied. So we're going to divide 6 by 3 and 4 by 3. If we get a whole number, like in the first factor, this is just going to simplify to x plus 2. However, with the second factor, when you cannot divide that numerator by the denominator and get a whole number, you're going to slide that 3 in front of the x. So the second factor will be 3x minus 4. And once we multiply it back, we're going to get the same expression that we started with. So if we did that, we'd have 3x squared minus 4x plus 6x minus 8. And when we combine the middle terms, this is what we're going to have as a final answer. And if you notice, oops, put the wrong number. If you notice, we have the same exact expression that we started with. So we're going to move on to the next example. So we're going to multiply a times c. So we're going to have x squared minus 17x plus 30. And with this one, we could break this down as x minus 15 times x minus 2. We'll get the positive 30 when we multiply, negative 17 when we add. But we just cannot forget the key rule of going back and now dividing those factors by a. So when I do that, my first one is going to turn into x minus 3. And then my second factor, because we cannot divide and get a whole number, this is going to turn into 5x minus 2. And if for some reason, if this equation was set equal to 0, all we have to do is set these factors equal to 0. So we'll have x is equal to positive 3 for the first factor. And the second factor, once we complete it, we'll have 5x is equal to positive 2. And after we divide, we're going to get x is equal to 2 over 5 as a final answer. Method number 4 is going to be the AC method. And this is very similar to the slip and slide method. So we're going to multiply a and c to get negative 6. And we know that the two factors we choose are going to have to add to give us our b term, which is 5. So the factors we're going to use are positive 6 and negative 1. And what we want to do to factor is substitute 5x with our two new factors. So we rewrite this as 2x squared plus 6x minus x minus 3 is equal to 0. And this is when we use factor by grouping. So we group the first two terms and the last two terms. And we're going to use GCF factoring to simplify where we can. So the first parentheses, we take out a 2x. We're left with x plus 3 on the inside. The second parentheses, all we can do is factor out a negative 1. Once we take out a negative 1, we're left with x plus 3 is equal to 0. So right now, we'll notice that two factors are the same. So we know that's correct. So we have x plus 3. And then the two outside terms we combine to get 2x minus 1 is equal to 0. So we set our factors equal to 0, and we're going to have x plus 3 is equal to 0. So x is equal to negative 3. And in the second factor, 2x minus 1 is equal to 0. We'll have 2x is equal to 1. And then we'll have a final answer of x is equal to positive 1/2. So the AC method is very helpful because you don't have to divide the factors like you do in slip and slide. Now, problem number 2, even though we've done this one already, we're going to do it with the AC method as well. So we know that when we multiply, AC is going to give us 30. But when we combine those two factors for B, it's going to give us a negative 17. So we know those factors are going to be 15 and 2. And when we double check the signs, which is very important, we're going to notice that we're going to have a negative sign for both of them. And then we're going to substitute. So we have 5x squared minus 15x minus 2x plus 6. So when we now do factor by grouping and group the first two and last two terms, we could pull out a 5x in the first one. We're left with x minus 3. And in the second parentheses, we're just going to pull out a 2. So what we're left with is x minus 3 again. So when we simplify, we'll have 5x minus 2 for the first factor times x minus 3. And this will give us the correct answer. Method number 5 is going to be group factoring. So we come in here and we're going to separate first two terms and the last two terms. Just be mindful that if this is a negative sign, do not group it inside the parentheses. It needs to stay outside unless we're going to get the wrong sign when we factor. So we're going to take out a x squared in the first set of parentheses and we're left with 2x minus 3. And in the second parentheses, we're going to pull out a 9, which will give us 2x minus 3 in the parentheses. So when we combine our answers, we'll have 2x minus 3 times x squared plus 9. Now, before we go on to the next example, let's just imagine that this 9 was a negative, meaning we had 2x minus 3 times x squared minus 9. This is going to happen probably 50% of the time or most of the times, meaning we're going to have to break this down because this is the difference of squares. There's an additional step. So our answer, if this was x squared minus 9, first factor is the same, but our second factor would then turn into x plus 3 times x minus 3. So just please be mindful in case you have a problem like this. Now, the second example, we have a trinomial, but even with trinomials, we could use grouping, especially if we use the AC method. So when we multiply A and C, we're going to get negative 12, and we know that the factors we choose have to add to give us a negative 1. So our factors are going to be 4 and 3, and if we need a negative 1 when we add, larger number will be negative. So now we substitute 2x squared minus 4x plus 3x minus 6 is equal to 0. Separate the first two and the last two terms. We could pull out a GCF of 2x, so we're left with x minus 2. And then in the second parentheses, we could pull out a 3, so we're left with x minus 2 for the second one. So we combine our factors, so we have 2x plus 3 is equal to 0, and we have x minus 2 is equal to 0. So we know x is equal to positive 2, and then in the second one, after we subtract 3, we have 2x is equal to negative 3. And then once we divide, we know our second factor, x is going to be equal to negative 3 over 2. Method number 6 is going to be factoring perfect square trinomials. So when we factor a perfect square trinomial, what's going to happen is we're going to have either a plus b squared or a minus b squared. So it's basically going to be the same binomial multiplied by itself. And there's a simple formula for us to factor this. So we know that it's going to take the format a squared plus 2 times ab plus b squared. So when we look at this, right, the square root of x is just x, and the square root of 16 is just 4. And once we square this, we're going to get that same expression when we multiply it back. So we're going to have x times x, which is x squared, x times 4, which is 4x, and then we go to 4 and we distribute. So we're going to get 4x again plus 16, and when we combine our like terms, we'll have x squared plus 8x plus 16, just so that you guys could kind of understand how it works. Now, when we go over to the second example, we notice that 5x or 25x, I'm sorry, is a perfect square. It's going to be 5x, and 36 is a perfect square. It's going to be 6. Now we're focusing on the middle term. So if we take 2 times a, which is 5x, times 6, is it going to give us that middle term? It is. We'll have 10x times 6, which will give us 60x. So this is a simple way just to check real fast. So if we put this together, we'd have 5x plus 6 squared for the perfect square trinomial. Now, if it doesn't fit this format, it just means that it's not a perfect square trinomial. However, you could still factor. Now, when we go over to our bottom left expression, scroll up some, what we're going to notice is that this is a negative sign, but it's going to take the same format. So a squared minus 2 times ab plus b squared. So when we look, square root of x is just x. The square root of 64 is just 8. If we multiply a negative 2 times 8, we get negative 16 times x is negative 16x. So we know this is going to be x minus 8 squared. And yes, this is a perfect square trinomial. Now, our last example is a funny one because 1 is a perfect square, but a lot of students kind of forget this. So we look at the first expression or the first term. 49 is a perfect square. Its square root is 7. X squared square root is x. And then we just put the 1 at the end because it's a perfect square. When we do a times b, 7 times 1, we just get a negative 7. And then when we multiply that by 2, this is how we're going to get the negative 14x in the middle. So just know how to also identify perfect square trinomials because it's going to be very helpful for our next method. Method number 7 is going to be completing the square. And completing the square we typically use in 2 situations. When we can't factor using our other methods, or when we're trying to quickly go from standard form to vertex form so we could identify the vertex if we are graphing. So what we normally want to do is just move that c term over. So we have x squared minus 2x. Remember, we're going to fill in this c term, and this is equal to 15. Now, for us to do that, we're going to take half of the middle term. So half of 2 is just 1. 1 squared is just positive 1. So we're going to add this on both sides. And then from there, right side simplifies to 16. Now we want to factor the perfect square trinomial to its binomial. A quick way to do that is just divide your b term by 2. So 2 divided by 2 is just 1. So x minus 1 squared. If we expand that, it will give us that trinomial at top. So the next step that we want to do to solve this is to take the square root of both sides. So exponent and radical cancel each other out. We're left with x minus 1 is equal to plus or minus the square root of 16, which is 4. We add 1 on both sides to isolate x. X is equal to 1 plus or minus 4. And then we just solve the equation. 1 plus 4, x is equal to 5. 1 minus 4, x is equal to negative 3. And we solve the quadratic equation. Now, in the second example, what they sometimes do is they will not give it to you in standard form or with the equation set equal to 0. So we have to be mindful of that. So we're going to add 46 on both sides. So we have x squared plus 2x is equal to 48. We take half of the b term, which is 1, and when we square it, it's just 1. Add it on both sides. Right side simplifies to 49. The left side, when we break this down to its binomial, this is going to be x plus 1 squared. Now, before we solve, if we were talking about switching from standard form to vertex form to identify the vertex of a parabola when we graph, we would have x plus 1 squared is, minus, my bad family, minus 49 is equal to 0. So when we identify the vertex, it would be -1, -49. If we did this for the second example right here, we would have x minus 1 squared minus 16 is equal to 0. So if we wanted a vertex for that quadratic equation, the vertex would be at +1, -16, just so that you guys also know that as well. But if we continue on with the problem, let's erase real quick. At this step, we will get rid of the we'll get rid of the exponent by taking the square root of both sides. So we have x plus 1 is equal to plus or minus the square root of 49, which is 7. So we isolate 7. X is equal to -1 plus or minus 7, and then we could solve. So x is equal to -1 minus 7, which is -8. Or x is equal to -1 plus 7, which will give us a +6. Anytime if you want to check if these answers are correct, just plug them back into the original quadratic equation. And if it's a true statement, it means that it is a solution. If not, it will be an extraneous solution. The last example for completing the square is when we have a lead coefficient. And when we're completing the square, our lead coefficient has to be 1. I've linked the video down below how to complete the square when we have fractions. But in this situation, what I would tell everyone to do is to divide by 3. If we divide both sides by 3, we could have a lead coefficient of x squared plus 6x minus 5 is equal to 2. We're going to move that c term over. So we have x squared plus 6x is equal to 7. When I take half of 6, that's 3. We square it to get 9. We add that on both sides. Right side simplifies to 16. And then when I break this trinomial down to its binomial, right, 6 divided by 2 is 3. So we're going to have x plus 3 squared. If we want to get the vertex is going to be x plus 3 squared minus 16 is equal to 0. So my vertex would be -3, -16. But if we continue with the square root method like the other problems, we're going to get rid of our exponent, right? That's why we take the square root of the expression. Do the same thing to the other side. All right, so we have x plus 3 is equal to plus or minus the square root of 16, which is 4. Isolate x by subtracting 3. Now we have our answer. X is equal to -3 minus 4, which means x is equal to -7. Or we could have x is equal to -3 plus 4, meaning x is equal to +1. Method number 8 is going to be factoring the difference of squares. And before we even jump into the topic, please understand that it has to be a subtraction sign. If you see x squared plus 36 or x squared plus 9, something like this, we cannot factor it because it's prime. It has to be a subtraction sign. So please understand that concept. So when we look at the difference of squares, typically what happens is that both terms are perfect squares. The square root of x squared is just x, and the square root of 36 is just 6. So we rewrite the expression twice and just flip the signs. The reason why it happens like this is because when we multiply back, right, we'll have x squared minus 6x plus 6x minus 36. Those middle terms are going to cancel out. And when we simplify this expression, we get the first expression we started with. When we look at the second example, it's the same thing. So x squared is a perfect square. Square root is x. 225 is a perfect square as well. Its square root is 15. So we rewrite the expression twice, and then we alternate the signs. So in our second answer, this would be the answer. Now, with the problem number 3 and 4 in red, these are a little different because what they do is they do not give you a lead coefficient of 1, but the same rules apply. If you look at 64 and 81, you'll notice that they are both perfect squares. So the square root of 64 is 8, x squared square root is x, and 81, its square root is just 9. So we write the expression twice, and then we just flip the signs. So we know it's going to be 8x plus 9 times 8x minus 9. Same thing in the last expression. 144, perfect square, breaks down to 12. X squared breaks down to x. 49 breaks down to 7. So we have 12x plus 7 times 12x minus 7, and this will be our answer. Method number 9 is going to be the difference of cubes, and it's a little bit different than the difference of squares because we won't have that prime issue as often. So the difference of cubes are going to take two formats, a to the third plus b to the third, and once we break this down, it's going to break down to a plus b times a squared minus a times b plus b squared. Now the other format it could take is a to the third minus b to the third, and then we break this down as a minus b times a squared plus a times b plus b squared. So when we look at the first example, when we break down this problem, the first set of parentheses is just the cube root. So the cube root of x to the third is just x, and the cube root of 8 is just 2. So this is x plus 2 times x squared minus 2x plus 4. So this is how we would factor the first example. Now when we get over to our second example in green, same exact thing. So we break this down as its cube root. So we have x minus 4. Then we have a squared, which is just x squared, plus ab. ab in this situation is going to be 4x, and then b squared is just going to be 16. So this would be our answer for the second expression. However, what they'll do sometimes is give you a lead coefficient, like in our third example in blue. And with this one, we kind of noticed that we don't have any cube roots. So we may have to do something different, which is take out a GCF of 3. When we pull 3 out, our expression turns into 27 x to the third plus 8. Now 27 x to the third and 8, those are all cube roots. So we could break this down. So this is going to turn out as 3, right? That GCF we pulled out, times the cube root, right, of 27x to the third plus 8, which is 3x plus 2. Then we have a squared, which is 9x squared minus 6x, right, because we multiplied a and b to get negative 6x, and then plus b squared, which would be 4. So a problem like this is another way that you can use the difference, or the sum of cubes, I should say, to factor. Now, example number 3 is straightforward because 64 and 27 are both perfect cubes. So we break this down for the first expression, which is just the cube roots. So the cube root of 64x to the third is just 4x. Cube root of 27 is just 3. Then we follow the format of the equation. So a squared is just 16x squared, right? Plus ab, which is 12x, and then plus b squared, which is just 9. And before we go, I want you guys to understand that when we break this down, it's based off the first set of parentheses, right? So when we break it down, that is the a and b that we're using to do the a squared plus or minus AB plus B squared. Sometimes students don't understand that and they'll use the original expression. Method number 10, and the last method of this video, is going to be the quadratic formula. And the quadratic formula you could use to factor any quadratic equation or a quadratic polynomial. It'll always work. So if the other methods you're not good with, you could always use this to solve. So remember that that quadratic formula is x is equal to the opposite of b plus or minus b squared minus 4ac all divided by 2 times a. Now we just have to be mindful that the trinomial quadratic equation, it may not always be in standard form, so you may have to manipulate it. So in the first example in green, we're going to have to subtract 9. If you don't, you may have the wrong sign. So we're going to use 2x squared minus 7x minus 9 is equal to 0. This is what we're going to now use to plug into the quadratic formula. And if you look at 9, this is why we could get it wrong if you just do it from the first original step. One is positive, one is negative. So we simplify to get x is equal to the opposite of b. B is negative 7, so now it's positive 7, plus or minus b squared, which is 7 squared, minus 4 times a. A is 2. C is negative 9. And this is all divided by 2 times a. We know a is 2. So the first thing we're going to want to do is just simplify. So x is equal to 7 plus or minus, let's see, 49 plus 72 all over 4. So when we add 49 and 72, we're going to get x is equal to 7 plus or minus 121 over 4. To be real with you, math family, most times what's under the radical is not going to be a perfect square. So just if that does happen, you just break down the radical to the simplest form, and then you could leave it like that. But in this problem, we're going to simplify since we can. So x is now equal to 7 plus or minus 11 all over 4. And we can use some mental math just to solve this. So 7 plus 11 is going to give us 18. If we divide by 4, we're going to get x is equal to 18 over 4. We can reduce that to 9 over 2 or even 4.5. I would just tell you always reduce to your lowest terms, whether it's a fraction or you convert it to a decimal. Then when we go back again and repeat this process, we have x is equal to 7 minus 11, which is negative 4. And then when we divide by 4, we know x is equal to negative 1. So our answers for that equation is going to be negative 1 or 4.5. If you leave it as a fraction, use 9.2. Now the last example it's a special case and you will see this. So again, we're going to bring this 12x over to the other side, set the equation equal to 0. So 7x squared minus 12x is equal to 0. This is what we're plugging into the quadratic equation. And family, anytime a term is missing, you just substitute 0 in for it and you continue solving like a regular equation. So once we plug this into the quadratic formula, x is equal to the opposite of b. We know b is negative 12, so the opposite of that is positive 12, plus or minus 12 squared minus 4 times a, which is 7, times c, there's no constant, we're going to put 0, all over 2 times a, like I said, that a is 7. So x is equal to 12 plus or minus 144 over 14. So we simplify this to get x is equal to 12 plus or minus 12, right? Square root of 144 all over 14. So this is going to be our answer. And if we simplify, we're going to get 12 plus 12, which is 24, and divide that by 14. So we have x is equal to 24 over 14. Remember, lowest term, so this could be 12 over 7. That's our first answer. And then when we go back to the second one, x is equal to 12 minus 12, which is 0. And when we divide 0 by 12, oops, I'm sorry, not 12, 14, we know that x is going to be equal to 0. These are going to be the 10 methods, family, that you must know to successfully factor trinomials, polynomials, and quadratic equations. If this video was helpful at all, please smash the like button for us, subscribe to the channel, and leave comments down below if you had questions on this video or if there's videos or topics you'd like to see in our future. Thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.